staying with triangles, and we're triangles. The first lesson is the Pythagorean Theorem. Two things about the Pythagorean Theorem. Well, one thing really. It only works on right triangles. Okay, so if you're given an acute triangle and you're going to try and find the side length, do not use the Pythagorean Theorem. It will not work. It only works on right triangles. This next thing I'm erasing, you already have this all typed out there under the Pythagorean Theorem. And the theorem states that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay. Last chapter, we looked a little bit at right triangles. You have one right angle. The side across from the right angle, that's called your hypotenuse. The other two sides are just called legs. Your hypotenuse will always be the longest side because it's across from the biggest angle. We learned that back in chapter 5. Biggest angle is across from the biggest side. Smallest angle is across from the smallest side. The theorem says that if you take the length of each leg, like let's pretend this one is 4 and this one is 3, if I square those lengths, so 9 and 16, and add that together, 25, that would equal what the hypotenuse is squared. Okay? Your picture has A, B, and C. Maybe your A and B are in a different spot. But your C will always represent the hypotenuse. So you can take all these words and write a single equation. A squared plus B squared equals C squared. C always represents the length of the hypotenuse. A and B are two legs. A squared plus B squared equals C squared. You can open up any different geometry book and that equation will be under the Pythagorean Theorem. Next year when you're advanced algebra, you'll use the Pythagorean Theorem. When you get to trig and calc, you'll use it. Your ACT, Pythagorean Theorem, and it'll refer to it the same way. A squared plus B squared equals C squared. Your hypotenuse always goes in for C. Capiche? Posh. Okay, we're going to jump down to example 1 quick. This says find the length of the hypotenuse of triangle ABC, and then it asks if they form a Pythagorean triple. So they know and tell me I'm trying to find the hypotenuse, so I'm going to put an X there. Your hypotenuse is always that C value, and then your legs are the A and B values. It wouldn't matter if you called 12A and 5B. The legs don't matter, you just have to make sure your hypotenuse is always C. Taking 5, 12, and X and plugging them into your equation at the top, you'd have something that said 5 squared plus 12 squared equals X squared. Order of operations, you have to square these first. What's 5 squared and 12 squared? And the sum of 144 and 25. So we've got 169 equals X squared. How do I make X squared X? Take the square root. Square root of 169, 13. Good. So the length of our hypotenuse would be 13 units, whatever it was. The second part of this question asks if these lengths, 5, 12, and 13, form a Pythagorean triple. Well, by definition, a Pythagorean triple is when you have 3 whole numbers that satisfy A squared plus B squared equals C squared. By satisfy, I mean if you put them into the equation, the left side would equal the right side. So if I plug 13 in for X, what's 13 squared? Does 169 equal 169? Okay, so it satisfies the equation. Are they all 3 whole numbers? Yes, then this is a Pythagorean triple. Okay, let's go to example 2. A right triangle has a hypotenuse length of 25 and a leg length of 10. Find the length of the other leg, and it asks if it's another triple. If you draw a picture, make sure that across from the right angle is where you put your 25, because it says the hypotenuse is 25. Then the other two are your legs. It wouldn't matter where you put the 10. Using your Pythagorean theorem, x squared plus 10 squared equals 25 squared. So x squared plus 100 equals 625. Subtract that over and you get x squared to equal 525. Take the square root. Does it come out evenly? Okay, I didn't tell you this, I'm sorry. If they don't come out evenly, simplify them down. Don't give me the decimal answer unless it says round or it says approximate. If it doesn't say that, then assume you have to make them simplified. 25 goes in there 21 times, so your x value would be 5 square root 21. Would these three lengths, 5 square root 21, 10, and 25, form a Pythagorean triple? Remember, they have to make the equation true and they have to be whole numbers. No, good. Having a square root is not a whole number. I mean, these are both whole numbers, but putting it square root 21, if you throw that in the calculator, it would give you a decimal answer. So a Pythagorean triple has three whole numbers that satisfy the equation. If there's a decimal, a fraction, a square root symbol, it's not a whole number. Please? Okay, do the next three on your own. So number 5 says the baseball diamond is a square with 90 feet sides. They're not talking about outfilled there. They're talking about the square formed by home, first, second, third, and fourth. So from home to first, 90 feet. First to second, 90 feet. It says home and second are at opposite vertices of the square. About how far apart is it from home to second? So we're trying to find this length here. Well, if the four bases make a square, then what kind of angle is formed at each base? A 90-degree angle. Good. So my square, when I throw that diagonal in there, becomes a right triangle. So what can I use to find that side length? Pythagorean theorem. Sorry, thanks for trying. So then 90 squared plus 90 squared would equal x squared. 8100 plus 8100 equals x squared. So 16,200 would equal our x squared value. About how far apart are they? In math, what does about mean? Estimated, approximated. You don't have to break down 16,200. You can just throw in your calculator, square root of 16,200, and approximate that value. Good. You take the approximated value, you should get about 127 feet. It is from home to second. Not only was my triangle a right triangle, how else could you classify that triangle? Good, isosceles, because I got 90 feet and 90 feet, so I'd call it a right isosceles triangle. Okay, that's your Pythagorean theorem. Seem doable? All right, the converse of the Pythagorean theorem, all those words. I'm not going to read those words to you. I'm going to explain it my own. The converse of the Pythagorean theorem will tell you what type of triangle you're working with. If it's a right triangle, an acute triangle, or an obtuse triangle based off the side lengths. So if I give you 3 side lengths, you can use your Pythagorean theorem to determine what type of triangle they make. If, when you put the 3 side lengths into the theorem, and you get a squared plus b squared to equal c squared, then you have a right triangle. If the left side actually equals the right side. If you put those 3 side lengths in, and your c squared is greater than, then you have an obtuse triangle. If you put the 3 values in, and your c squared value turns out to be smaller than the other 2, then it's an acute triangle. C squared smaller, acute, c squared bigger, obtuse. If they're equal, it's right, because that's what the theorem tells us. So if I look at number 1, they give me a triangle with side lengths 4, 6, and 7, and I want to determine what type of triangle it is. Using the Pythagorean theorem, a squared plus b squared equals c squared. Which of these 3 values do you think I should plug in for my c? 7. Good. You're always going to put the biggest value in for c, because in the real theorem, c represents the hypotenuse, which is your biggest side. When we're unsure, you're still going to put the larger one in there. So then I have 4 squared plus 6 squared equals 7 squared. And then you simplify it out. The left side would give me 16 plus 36, which is 52. The right side is 49. Are those values equal? No, so that means it's not a right triangle. Which of those two is the c squared, 52 or 49? 49, right? Is 49 smaller or bigger than 52? Smaller, so then this is going to be an acute triangle because c squared is less than. Okay, the next one. 10, 24, 26. Which one would we put in for the c part of our theorem? 26, good. So 10 squared plus 24 squared, 26 squared, 100 plus 576. Sorry, I did it a lot today already. You should get 676 equals 676. What type of triangle would it be then? This is a right triangle. The left side actually does equal the right side, so this is a right triangle. Go ahead and do those next three on your own. Linz, what kind of triangle did you get with that 10, 15, and 20 lengths? Acute? You guys agree with her? That the first one? I don't know. You may have. 10 squared plus 15 squared and 20 squared. This would be 100 plus 225, so you'd get 325. And then you got 400 over here, right? Okay, don't look at the signs, look at what c squared is. Is c squared, the one that's by itself, bigger or smaller? So then it's got to be obtuse. Does that make sense? Yeah. Okay. Andrew, what did you get for 16, 48, 50? You guys agree? Alyssa, how about 7, 8, 9? Obtuse, you guys agree? Seven squared, 8 squared, 9 squared. So 49 and 64 would give us 113 and 81. It should be acute because your c squared is smaller than it. Okay, so don't pay attention to the signs that I wrote above because they're backwards from when you put it in this way. So if your c squared is smaller, it's acute. If it's bigger, it's obtuse. Comprende? Bueno. All right, last one. The town of Elena is 24 miles north and 8 miles west of Holberg. A train runs on a straight track between these two towns. How many miles does it cover around your answer to the nearest whole number? Okay. What did I say this chapter was going to be about? Right triangles. So we should probably get a picture of a what? Awesome. Elena is 24 miles north and 8 miles west of Holberg. So they're giving us the directions based off of Holberg. So I'm going to start with Holberg and move from there. If Elena is 24 miles north of Holberg, which direction should I draw a line? Up. And then it's 8 miles west of this point, left or right? Left. Here's Elena. There's a train track that runs straight between those. They want to know about how many miles that would be. So you have to be careful with your right triangles too on where your legs are going to go, especially if they give you your cardinal directions. Did you get to a point that you got x squared would equal 640? Okay. And then it says round your answer to the nearest whole number. You don't need to break it down then, because they're already telling you you can round. So don't find the perfect squares that go into it. Just take the square root of both sides and round to the nearest whole number. 25? So it's about 25 miles. A little less, a little more than that though, probably, huh? Okay. Questions on your Pythagorean theorem? Cool.